Hi, I'm going to write a simple Naughts and Crosses game, sometimes known as Tic Tac Toe, in Java. I think the best way to learn programming is by actually doing it. So if you want to follow along, I'll do it in real time and you can see, I'll explain all the thought processes that I'm going through and you can copy along if you want. You can download Java from the Oracle website if you Google, if I just pull up a Google here, if you Google Oracle JDK, that should take you to Java SE downloads. If you download the latest JDK from there, and then as well as that you'll need the Eclipse development environment. So that you can get from eclipse.org. If you install those, you should be able to follow along this video and write your own Naughts and Crosses game. So let's get straight into it. So when we load Eclipse, we get here, we go to the workbench. Okay, so we're going to add a project to Eclipse. So we right click in the Package Explorer, New Java project. We're going to call the project Tic Tac Toe. And then in this project we'll make our main, make a package first, just call the package Tic Tac Toe, and then in that package we'll add our main class. So again, Tic Tac Toe. Now, just to make sure everything's set up okay, I'm just going to write a quick hello world. So the first method that runs in any Java program is the main method. To write that we do public static void main string array args, and we'll just system out print line hello world. Save that and we'll just run this, run as Java application, and just confirm in the console window hello world. So we know we've got everything, Eclipse and Java, everything's set up okay. So for Tic Tac Toe, the way we usually start a Java project is by creating the main class. So we'll make the constructor public Tic Tac Toe, and what we'll do in the main method now is create a Tic Tac Toe object. Now I'll make the data structure to represent the game. So I'll make a new package and I'll call this package model, and in here we'll make a new class, a game class. And now we'll think about how what a Tic Tac Toe game consists of. So it's 9 cells. Each of the cells can either be empty, it can be a naught, or it can be a cross. So I think I'll make an enum. I'll make it public because it'll probably be needed outside. Public enum cell. And the cell can either be empty, a naught, or cross. And then the game, I'll make this private because we'll access it through methods, is a 2D array of cells. And when we create a game in its constructor, call it 2D array board. When we create a game, we create a new board, cell array 3x3, and for each cell we'll make it empty. So for x equals 0, so for each row x, x0, and for each column board x y equals empty. Now when we create a new game, it will populate the board array with empty cells. Now what else might we want to do with the game object? Or we may want to check what's in a cell. So let's make a method for that now. Public cell get cell. We'll provide x and y coordinates, and we'll return the value of the board for x and y. And we may want to set a cell, so let's add a setter method. Void means returns nothing, this method. Actually, let's return a boolean, because we can only set a cell if it's empty. So set cell, the coordinates and the cell value. So if the board at those coordinates is empty, then set the cell at those coordinates to be the supplied value and return true. Otherwise return false, because we can't set the cell unless it's empty. So we're probably going to do much more to this class, but that can be our initial game class. Now I'll make another package called view, and we'll work on the graphics side of things in there. I prefer to see my packages hierarchically, so I'll just change that. I'll make a new class here. It's the user interface. I'll call it a console. Now let's have a think about what we want to do, what we want the user interface to look like. So I'm just going to load Paint and just do a sketch of how we want this to look. So obviously we've got our Naughts and Crosses board, so this is just going to be a really simple drawing. Naughts and Crosses board. So we've got 9 cells, and that can all be in one panel. So if I just draw, I'll do a rectangle. So I have a panel with the board on it, and then we might want some status information or some additional buttons, so we'll have another panel underneath. in that panel we can have a status message. So if we have a status message in here, yeah, this could say things like your move, my move, or I win, you win, whatever. And then we may want some buttons to say, so the player can select a new game or restart game. Maybe over here. It's just a simple diagram, but so let's see if we can create something like that. So the console, we'll make it a J-frame. So we're going to use standard swing components. The console extends J-frame. Control Shift and O to import the J-frame. And when we create the console, we'll construct the elements of it. So these can be buttons, so that when the user clicks on them, that's his move. And down here we want some text box and some buttons. So let's make a 2D array of buttons. So we want 9 buttons. J button, and we'll call it buttons 1 up. So again we want 1 button for each of the cells, and again I'll quickly go and copy the code that we did to initialize the game. But this time we're initializing the buttons. New J button. Now we're going to want action listeners on these buttons, so when we click them they fire off some code, but we'll think about that later. We'll just get the user interface looking right first. So this whole window, the J-frame, we're going to want to set it to a certain size. I don't know what I'm going to choose, but let's say a width of 200 and a height of 300. We'll fix that to look good later. And then these buttons, we're going to put them all in a panel, and that panel is going to have a grid layout of 3 by 3. So J panel, game panel equals new J panel, game panel, set layout, new grid layout. So standard Java layout, grid layout, and then as we create a button we're going to add it to the game panel. I may get confused about which one is X and which one is Y, but I think that I think we want to do Y before X. No, that's right, we want to do Y before X, because Y is going down, X is going across, so we want to, it will add it to the layout 1, 2, 3, 4, 5, 6, 7, 8, 9, so that means button X0, Y0 is the top left corner, X2, Y2 will be the bottom right corner. course we index arrays from 0, so it's a 3 by 3 array, but the values are 0 to 2 instead of 1 to 3. So now the whole panel will make this a border layout, and we'll put the game panel in the center, and then we'll have the control panel at the bottom. So let's first create the control panel. That's going to be the lower part of the diagram that I've drawn here, with status bar and some buttons. Actually, I think I'm going to make the status bar at the bottom. Actually, what I might do is I'll put the status bar at the bottom, and I'll have any buttons to restart the game up at the top. So I'll have a control panel and a status panel, but the status panel really is just one text box, so you don't need to create a panel for that. So control panel, we'll make this a layout. I think we just need one button. It can be start game and restart game, or we might give the user the option to play noughts or crosses. Yeah, so we'll give them 2 buttons. I'll set this to flow layout for now, and we'll just see how it works, how it looks. And we'll add a button for start. The start X button. For play with crosses, and start O button for play with noughts. We'll add both of these buttons to the control panel. And then our status area could be a JText area. And then the whole JFrame can be in border layout. So in border layout we have the center, which would be our game panel, and then we have north, south, east and west. So we'll make the control panel north and the status south. So this, because it's this object we want, set layout, new border layout. And when we're using border layout, we add things with a border layout parameter. So this add we want to add we'll add the game panel to border layout center, spelt the American way. We'll add the control panel to the north, and we'll add the status, which is not a panel, it's just a text area, to border layout south. Then back into our main class, we'll just create the console for now and see how it looks, and then we'll tweak it. Console equals new console. And console, we need to set it visible. Java JFrame is not visible by default, so you have to set it visible. We'll also add a window listener. If we go new window listener, Control Shift O to import that, we can right click here, we'll add unimplemented methods, and it's the window closing one I'm interested in. What I want to do if the user closes a window, I just want to exit with a 0 return code. Now adapter classes are like complete listener classes, so when we make a window listener we have to define all these methods, but we only want to define one, so we can use a window adapter, window adapter there, and we can delete all the methods we don't want. So let's try and run that and see what happens. Okay, so the windows appeared, but as is typical, it's not right at all. We seem to have our 9 buttons going across, of the Start X and the Start O button that we wanted, and the status down there. When we click close, the application closes, so it's just the way the buttons look that seems to be wrong. So did I remember to set the grid layout into 3 by 3? No, I didn't. So fix that, and that should work. Okay, so this is what we wanted. Now I'm using a second monitor, so I'm going to you don't need to do this, but I'm going to set the position, the start position of the window in console. So set position, because I want the window to appear on the monitor that you can see. Set location. I don't know the resolution of my monitor on the left, but let's try 1500. Come on, 50. Okay, so that appears there. Right, so first we want the console, the status to say click start button. And notice I'm doing small changes and then checking that things work. So what do we want to do? Okay, so we'll say that the X is always going to go first. So if the user plays the cross, he goes first. If he plays the naught, the computer goes first. Now this Tic Tac Toe class I'm going to use as the controller, but we need this to know when the user presses a button. So I'm going to add an interface, a controller interface. So I'll add a package. And I'll add an interface that we're going to pass into the console, and then this Tic Tac Toe class will implement controller functions that are defined in that interface. So new interface, I'll just call it controller. Okay, so this interface is going to define methods in the main Tic Tac Toe class that can be called from the console. So really it's button clicks that we want, so we'll have public board click with X and Y coordinates. So that's a method that will be clicked when method that will be called when the user clicks on the board, and also public void start button pressed. Let's make an enum for this side. Naught cross. And then in the controller we'll have the side notified to the start button press method. So now the Tic Tac Toe class is going to implement that controller. Implements controller. And that means it needs to define these methods. So there we've just added the two methods automatically, and then when we create the console we'll pass the controller to it. We'll save it in here. And this controller, meaning the one in this object, equals controller, meaning the one that we passed into the constructor. So now we'll add action listeners to all of the buttons and we'll test them out. So we can test these methods just by outputting them to the console. So system out print line board clicked at X, Y, and here start button clicked for side. So that's just temporary debug code that we're going to do to make sure that when we click on the buttons the right methods get called. So in the console we need to add action listeners to all the buttons and call those methods in the controller. So for the start buttons it's nice and easy. Start X button, add action listener, new action listener, action listener just has one method, action performed. For that we can just call controller start button pressed or side cross. And we'll just repeat that for the Naughts button, start O button, I'll just test that out for now because I think it's going to be a bit more complicated with this these for loops array. I've got an error I need to provide this, which is this object which implements controller into the constructor of console. Start button click for cross, start button click for naught. Of course they don't do anything yet. Okay, so for the other buttons, we want to add a listener on these, but we can't refer to the X and Y variables. So what I can do is add an action command. Add action command, set action command. For that we can just do X plus comma plus Y. So I'm setting the action command of the button to be X comma Y, and then we'll add a listener. We'll make console an action listener. I don't seem to be able to get to that method, so I'll just add it from here. Then we'll add XY. We'll add the console as the action listener for those buttons. We can get the action command from the action event. So string action command equals r0.get action command. Then we can split it in two by action command. Split with a comma, and then int x equals integer value of the first part of that, and then y equals integer value of the second, and then we should be able to call controller forward click x comma y. Now I'm not worrying about what happens, that things can go wrong here, because if that isn't exactly x comma y, if something else is passed into here, that could easily go wrong, because maybe we can't make an integer out of just some bit of a string. So there are things that could go wrong, but I'm not worrying, because for the sake of making this video concise, I'm just doing a bit of sloppy programming there. So back to board click. When we click a button now, we should have this method called. So let's test that out. Board click at 0, 0, 1, 0, 2, 0. Just test them all the way up to 2, 2. Start X, start naught. Now we're ready to actually start programming the game itself. Right, okay, so in the console I'm going to make a game on and game off flag. When the game is going, I want the buttons of the grid to be active but the start buttons to be disabled, and when the game's not going, I want the console to display click a start button, I want the start buttons to be active but the game buttons not to be active. So public void set game on, I suppose. Boolean game on. So in here, if game on, for each button in the button grid, so I'm just going to copy that for loop there. Buttons X, Y, set enabled true. But start button, start X button and start Y, start O button, set enabled false. Now an easier way of doing this, I realise that I'm going to say if game on, do all that, else do it all again. What I can do instead of doing the true and false in the there, I can say set enabled game on. So if game on is true, you set those enabled, and here set enabled not game on. And then I also said if not game on, we'll set this message. Now it's always better to put strings, define them. This is especially useful if you want to do like foreign language internationalization, to have your strings defined separately. String click start message equals that, and then on initialization we can actually I'll just leave that blank. Because we'll call this method if not game on status set text click start message. And then in the controller class we've created the console. We'll just set console set game on to false. So now when we run, we can't click these buttons. We've got the click a start button and we can click those. So now we need to think what happens when we click start. So we go into here, we want to start the game. We'll keep a track of who's playing in here. In the game we've already got an enum defined for side. So here we'll say private side player side. So here we'll play player side equals side, and console set game on. We haven't saved the console in this class, so let's just put it outside of the method. Console set game on true. And we'll also have in game, we'll keep track of whose turn it is. So when this happens, we want to create a new game object. If you remember, the game, when it initializes to empty. So we'll have a current game object. So we say current game equals new game. And in game we'll keep track of whose turn it is. So say private side current turn, and we'll always start that off with cross, and we'll make a getter and a setter, so we can generate that automatically. A getter and a setter for current turn. So let's just see what happens when we click the start button. That switches off, this switches on. That's what we want. Right, so when the user clicks on the board, we're going to want to set a cell. So depending on the side the player is playing, so when the user clicks on the board, I'm going to want to say current game set cell XY to the player side. Set cell takes parameters into game cell. Cell is empty, naught or cross. There's a difference between cell and side, so we need to do that conversion. So if player side equals side dot cross, current game set cell dot cross, else if player side equals side dot naught naught, else something's gone wrong because the player side is not naught or cross. It has to be, but well, just in case. Player side is not naught or cross. And I'm also going to add to console a refresh method with game, where it will set noughts and crosses depending on the state of the game. So console public void refresh game. So this is going to refresh the cells in the game to reflect the cells in the console to reflect the state of the game. Notice that we're keeping the game data structure and the graphics separate. That's just good practice because we might want to rebuild the user interface without rebuilding the game logic. So for each cell in buttons, game, do we have a method in game? Game.get sal xy, and that gets us a sal. So if game xy equals sal.empty, we want to set the button text to nothing. In fact, we can do switch game get sal x.y, and we can fill in all the cases. So there's cross, empty, naught, or default. I suppose default should be the same as empty. So what we can do is get empty there, but don't break it. So empty is the same as default, which is nothing. If it's a naught, we want to put an O in there, and if it's a cross, we want to put an X in there. So what have we done? So the user will click a button, it will set the sal for the user, and then we want to console refresh with the state of the game. Game. So now we'll take it one step at a time. The user can start X, and then he can put X's everywhere. Right, now let's just think one step at a time what we want to happen there. So start X, when the user clicks a square, we only want that square to be accepted if it's empty. So forward click, we only want to take any notice of this if current game get sal xy equals sal.empty. Otherwise we'll just ignore the click. You're not going to be able to see that happening now because obviously we won't know whether we're reacted to that or not. But here we want to make computer move, so I'll just make a note there. Computer move. Or click to XY. Computer move. Right, so we also want to change this click a start button. So we want to say that your move. But we have to think about whether the computer should go first or second. So here we can say console set. We don't have a set status yet, do we? But in console, we'll add a set status message. And that will just set the text of the status bar. Status set text. Oh, string status message. So here we say console set status my move. computer move. And that's going to be, computer move is going to be the interesting bit really, where we think about how the computer should play. But for now, we'll just say current game set cell 2,2, and then we want to set it to the opposite of what the player's playing. So player side equals cross. Set it to naught. I'll set player side equals naught. Set it to a cross. So the computer move is just going to play in cell in the bottom right hand cell and then go back to your move. So that's going to happen pretty instantly, so I doubt we'll even see the my move method, but we'll see how it looks. So if we start X, you click the cell, and it didn't do that. It did the second time. That's because we didn't refresh it. Okay, so after the computer move, we need to refresh the game. Start X, play 0. If we start again and start O, we play O and the opponent plays X. I think that really belongs in there. So when the board is clicked, we play where if the cell is empty, we play the player side, we refresh the game, we make the computer move, and we refresh the game again. Obviously we need to check whether somebody's won, and we need to add some logic to the computer move to make it intelligent player. Okay, so the next thing I'll do is add a check after both the player move and the computer move to see if somebody's won. Now because I've got a computer move method, I'm going to add a player move method. So the player move is it worth doing this? No, maybe it won't. I'm building a sort of game loop logic in this board click method, but that is what fires it all off, so I'll forgive myself. So console refresh current game, and then we'll ask the game if somebody's won. So we'll add a method to game, public side get winning side, and we'll either return naught if naught has won, cross if cross has won, or null if nobody's won. Get winning side. So what we want to do is check every row or column or diagonal to see if the value in them is all the same. So I'll start off with a for loop like this, starting with x, y. So for each x, for each y, is this the easiest way to do this? Actually, if I say if get cell equals get cell, I may end up putting it in a loop, but I'll start off like this. If get cell 0, 0 not equal to cell dot empty. If get cell 0, 0 equals get cell 1, 0, and if get cell 1, 0 equals get cell 1, 2, then the winning side is whatever value that is. But get cell, of course, is a cell, whereas the winning side is side. So if get cell equals cell dot naught, turn side dot naught. If get cell dot cross, turn side dot cross. Now I think what I'll do is I'll put another method, private method, get winning run, and then it will take 6 parameters defining 3 different cells. Cell x1, cell y1, cell y2, cell y3. And I get most of that method, or the whole method, and put it here, and I'll say cell xy1 is not empty. If cell xy1 is the same as cell xy2, and it's the same as xy3, then return the side. Otherwise, return null. So what I'm saying, I'm supplying 3 cell coordinates, and if that doesn't return null, then those 3 coordinates are all the same, either naught or cross. So here I can say side winning side equals null, and then if get winning, so winning side equals get winning run, I just need to supply all of the combinations, so 0, 0, 0, 1, 0, 2, if winning side not equal to null, return winning side. Yeah, put that in there. It's a bit messy, but this is how I'll do it. So how many we've got? 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So we've got 0, 0, 0, 1. We've got 1. So all I'm doing here is every possible set of 3 squares. So that's the 3 rows, 3 columns. Or just these with the X and Y reversed. Just going to copy these to here. So I'm sure there's a better way of doing this, but this is just an easy way of doing it. And then the diagonals are 0, 1, 1, 1, 2, 2. And 0, 2, 1, 1, 2, 0. And if none of those win, return null. Okay, so after the player moves and after the computer moves, we want to see if the winning side is not null, and if it is, we finish the game. So that was in game. Get winning side. Current game. Game get winning side equals player side. And the players won. Side winning side equals current game get winning side. If winning side is player side, we want to set a status. So console got set status U1, and also console set game on false. Else if winning side is not null. If it's not the player side and it's not null, then the computer won. Now we're going to want I win. I won. I win. We're going to want to do that after both the player move and the computer move, so I'll add it to a method, private boolean It can return true if there's a win. Check for win. So in both cases of I won and you won, we return true. Otherwise we return false. So console refresh current game. If not, check for win. So it'll call that method and then carry on if not win. And again here, if not, check for win. So here I'm saying refresh the game. If nobody's won after the player's move, then set the status to my move and make the computer move. And then if nobody's won after the computer move, set the status to your move and refresh the game. We want to refresh the game. Okay, so let's see if we can win. Remember, the computer's playing the bottom right hand corner every time, even if it's already taken. So we should be able to X, X, X and win. Okay, so we've got a bit of a problem here that as soon as we click this winning move, it immediately says click a start button. So instead of saying you won. So I'm going to change my mind about that start status. And if we go into console, in the game on method, I'm not going to set the status text again there. I'll comment it out in case I change my mind. But if what I think is better is just to hold you won. So your move, you won. And then we can start again. I think that these buttons have become active again. It's sort of clear that we can start again. And we're only making a simple application. Again, I've started and the game is stuck like that. That's because we haven't refreshed the game. So when we create a new game object after pressing the start buttons, we need to refresh the console. I think that's not the only problem, but let's deal with that one thing at a time. So when control the start button is pressed, that's the interface, start button pressed, current game, new game, console, refresh, current game. See, it's really worth developing a little bit at a time and testing, because you can never think through everything that might happen. So start X, your move, you won. Start X, it's not saying your move, you won. So the first thing I want to deal with is where we click start. I want it to say your move or my move. And the other thing we need to consider is it's the player's side. If he chooses to play X, it's his move. If he chooses to play noughts, then the computer should move first with X. So let's have a look. You want start X, you want to update status, player side. Okay, so this board click method, I am going to separate some of this out now. So board click, I'm going to make a method next turn. I'm going to get this out of it. So in game we've got that current turn flag, which I think I've forgotten about. But if game get current turn, current game get current turn equals the player side, then it's the player's turn. So if not, check for win, player's turn. Else it's the computer's turn. And that next turn should happen at the start as well. So if the computer's playing crosses, it goes first. So start button pressed. Next turn. I haven't really thought this through, so we'll have to test this quite thoroughly, but we'll take it one step at a time. So if we play X, it's your move. The computer's not moving because we're not changing the side. If we play O, the computer moves, but it always sticks on my move. Okay, so there's a lot wrong with this. So we need to change the move. So in game, if the player plays a move, in game we'll add a method to switch the side, meaning that the player has moved and switched to the other side. So near it get current turn method, we won't have a set current turn method, we'll change this to switch side, switch current turn. If current turn equals cross, then current turn should go to naught. And I think we'll not bother checking the other way because there's only two possible values for side. So switch current turn. So when the player makes a valid move, current game, switch current turn, and then next turn and once the computer's decided its move, so the final thing the computer will do is switch current turn. So is that everything? I don't think so, but start X, your move, computer move, it sticks on my move. U1 start O, computer move, sticks on my move. U1. I think the only problem is it's sticking on my move. So let's debug what's happening. At what point does it go wrong? Your move, I click a button, it sticks on my move. So after the board click, we'll put a breakpoint here and run in debug. So this is going to happen when we click button, switch to debug mode, and we'll step through the program one step at a time. Let's see what's happening. So board clicked. Take a step, we expect this to be empty. Player side, current game set sal, console refresh, switch turn, go into the next turn. Current game, it's player side, else my move. We need to call next turn after computer move. That's the problem. Okay, so I think the only thing we've got left now is to do the computer logic where it's going to play. Let's just check everything's working. So start X, your move, click, move, click, move. U1. I suppose, check some different ways of winning. U1, start O, U1, start X. Okay, that all seems to be working. So now let's think about the computer logic. So this is all in the computer move method. Right, so I need to think about how best to play Naughts and Crosses. Now, I think I recall the best thing to do, the first thing you should do is try and win. If you can win in the next move, do so, obviously. The next thing you should do is stop your opponent winning. Then if your opponent can't win in the next move, you should go in a corner. If you can't go in a corner, you should go on an edge. And if you can't go on the edge, you should go in the middle. Now, let's just try that out and we'll see how that works out. So the computer move. So we want to select our coordinates. So we want to ask the game. I think we might, to game, we'll add a method where we can ask it if a side can win in the next move, and to give us the coordinate of that side. So we might add a new object, a sal object with a coordinate object that we can pass back. So in model, I'll just add a simple class, a coordinate class, and that coordinate is just, I'll just add a public int x and a public int y. I'll create a constructor so we can just create it in one line with x and y, and I'll add getters and setters. Getters and setters, methods that we can set and get the value. That's kind of now a general purpose XY coordinate class. I think what we'll say is computer move, player side. So first we'll work out what side we're on. Side, computer side. If player side equals side dot cross computer side equals side dot naught, else computer side is side dot cross. So I'll put some pseudocode in here. So first, if computer can win, do so. If player can win in next move, block. Pick a corner, I think, is the next best thing to do. I'm not sure about that. Pick an edge. And finally, go in middle. Of course, some other logic we haven't dealt with yet is what happens if nobody wins. So we're going to have to add that to the, maybe for the check for win, we'll change that to check for finish. If the board's full, then it's a draw. So I'll rename that method now, actually. Refactor rename. Check for finish. And I'll put a to do in here. Say if board is full, it's a draw. So we can't get that to happen until the computer's actually playing, so I can't really test that yet, so I'll just leave that to do in there to do later. So we know what side the computer side's on. We've got a compiler warning there just because it's not, the compiler's not sure whether that may be null. We know it's not going to be because it's going to choose one of these. But I'll just initialize it to null to get rid of the compiler warning. Still not happy. It's now a compiler warning because it's not used, but we will use it. Okay, so I want to be able to ask the game to give us a cell that will be a winning cell for a side that we specify. In game, so I'm going to return a coordinate object, get winning move for a side. So if we ask it for the get winning cell for this side to win in the next move, we'll return null if there is no winning move. So is this more of this listing things? How many combinations would there be? 1, 2, 3, 4, 5, 6, 7, 8. So oh no, there's many. I think I need to loop through the cells. I can set the value and then I can unset. I can check to see if there's a winning. What I can do is I can loop through the cells. If the cell is empty, I can set the value, call get winning side, and if it's this side, then unset the value and return so I'm going to try and put, if the side is full crosses, I'm going to try and put a cross in each box, then call get winning side. If we've won at that point, we know we can undo that move and return that cell. If we haven't won at that point, we'll just undo the move and loop through to the next. So I'll take a copy of the for X and Y loop again. If the board is empty, double equals for comparison, then set board. There's a difference between side and cell again, so cell value equals null if side equals side.naught, cell value equals cell.naught, else cell value equals cell.cross. So board X equals cell value, and then if get winning side equals side, equals side, then we want to set that back to empty, and return the coordinate x, y. Else, we want to just set it back to empty. So that's not quite right, because what we should really do here is boolean win equals false, and here say win equals true, so that we've only got one. This line and this line are doing the same thing, so we want to do that anyway. But then if win, the other way round, I had a line of code that was doing the same thing twice, and if for some reason we had to refactor that line of code, I might forget to do it on the second instance of it, so it's better to do it this way. So assume we've not won. If winning side is side, we've won, and return the coordinate. So we should probably test this method with some unit test or something, but for the sake of the video, I'll just see if it works when we play against the computer. So if computer can win, do so. So coordinate winning cell equals current game get winning move for computer side. If winning cell is not null, then we're going to win. So current game set cell I should probably reuse that coordinate here, but I'm not going to. Winning cell x, winning cell dot y. Player side cross. Okay, we'll also work out the side here. So if player side is side cross, computer cell. I should probably have made the side and the cell object the same, but the difference is a cell can be empty, whereas a side is just either naught or cross. So computer cell equals cell dot naught, and then computer cell equals cell dot cross. So if winning cell is not null, win. Else the rest of the logic. If a player can win in the next move, block it. So coordinate losing cell equals current game get winning move for the player side. If losing cell is not null, play into the losing cell. Else pick a corner, pick an edge, go in middle. So I'm going to do this for each corner. If current game get the cell, so the corners are naught equals cell dot empty, play for naught. Now I'm going to have a big load of nested else's here. Wow. I think I'll put this into a separate method to save having loads of nested else's. Void computer pick cell. Else computer pick cell, because we can literally return out of the method as soon as we've done. I might even make another method, computer consider cell, with int x and int y. Computer's consider cell is basically going to look at xy. If it's empty, it's going to play it. We still need the computer cell value to be coming through, so pass this through. If it's empty, we'll play it and we'll return true. If it's not empty, we'll return false. So pick a corner. If computer consider cell 0, 0, computer cell, return and we want the corners, 4 edges. Now it shouldn't get this far if it's the middle, but that method's going to return anyway, so we should perhaps put an error here. We wouldn't expect to see this, but picking, so error for computer picking. So the corners are 0, 0, 0, 2, 2, 0 and 2, 2. The edges are 0, 1, 1, 0, 1, 1 and the edges 0, 1, 0, 1. 0, 1, 1, 0, 1, 1 is not a edge, 1, 1 is the center. The other edges are 2, 1 and 1, 2. Yeah. Okay, so is that everything? I think now the computer should now play intelligently if what I said about corners and edges is intelligent, which I'm not sure it is. But let's see. So start X. So we play, the computer's made 2 moves. We play another and the computer wins. Okay, let's just start playing for for naught, see if computer's played 2 moves again. Okay, so quickly browse through and see. Did I keep in this 2-2 logic? Is that the logic? Yeah, this before was the bit where we were just putting a value in the bottom right hand corner. So we don't want that to be happening anymore. So computer plays 1. He's blocked it. We blocked him. If we don't do this, let's see if he wins. You won. Oh, I did win. Yeah, okay. Let's try and get him to win. So I'll do there. He's blocked it. I'll go there and I win. Start O. Your move. He didn't play. Oh no, he's blocked me there. It seems to be reasonably okay, but now we've reached this draw position, which I just need to check for because I can't get out of it now. So we definitely don't want that. That was definitely temporary code. So now I think we just need to check for a draw, and then we'll play a few games and see if it seems to work. So we'll ask the game if it's full. So public boolean is board full. And what we'll do is we'll go through our twin for loop, and if the cell is empty we'll return false. So for each cell, if the cell is empty, return false. If we get through both of our for loops without finding an empty cell, return true. The board's full. Obviously it would be good practice to put comments on these methods, because if I revisit this code in the future it may be worth knowing what's going on, but I'm just throwing this game together, so I won't bother with that. So if board is full, it's a draw. I'll leave that comment there. If current game is board full, it's a draw. So what do I do then? I say console set status draw, console get game on false, and return true to say we finished. I think that's everything. So let's test. So if I play X, it's my turn. Move, block that win. That's a draw. That's good. If I play O, he goes first. I'll try and force a draw just to check that draw works. Ah, he wins. Play O. How do I force a draw with O? Go in the center, I think, and then just block every. Yeah. Draw. Can I win if I go opposite? I could win. It may not be. I'm not sure whether this is absolutely the best artificial intelligence. There's probably some condition, some way of never losing. I'm not sure. But perhaps if you've copied along with this game, you may want to improve it. You might also want to facelift it, you know, make it look better, maybe paint some lines in, change the font in the button. If you can work out how to do that, it could definitely look better. And so that's it for our Naughts and Crosses game written in Java. If I'm going to continue to make programming videos, I'm not sure how often, but if there's anything in particular you'd like to see, or if you've got any questions about this, if you think this video's been too difficult or too easy, then leave a comment and I'll try and answer your comments. If you've learned something from the video, give it a like, and if you'd like to see more videos like this, then subscribe. Thanks for watching.